In this video, we are going to be looking at parallel lines, and we're going to be doing two examples of finding the equation of a line that is parallel to another line. Question 1. Determine the equation of g of x if the lines are parallel. Okay, well, first of all, g of x is just a different notation that represents y. And why do we use it? Because now we've got two different functions on the Cartesian plane, and we just use it to distinguish between them. The purple one is g of x, and the orange one is f of x. They're also saying that these lines are parallel. So what does that mean? If lines are parallel, they share the same gradient. So think about this with me. These parallel lines over here, the distance between them stays constant. So if you think about that orange line, it's got a certain steepness, slope, and because they are parallel and the distance between them stays the same, surely the purple line will have the same steepness to the orange one. So you need to know that parallel lines have the same gradient. Okay, so let's jump in and go find g of x. Now, if I go straight to the purple line, g of x, the one that we're supposed to find, there isn't enough information there to find the line. Since it is a straight line, we know that it will be in the form y is equal to mx plus c, but we only have 1 point on g of x, and that is not enough to find its standard form, to find its equation. They did give us a good point though, which is the y-intercept. So we know that our c will be 3. So y is equal to mx plus 3. That is what we know so far, but we don't have that gradient. So we're going to have to make another plan. Let's use the orange line to see how we can use that one. If we look at the orange line, there we were given more information. We were given its y-intercept, thereby -1, and we were given another point. So since what we need in our first line is the gradient, let's use the orange line to find its gradient, because then we've got the gradient of our line, our purple line, because parallel lines share the same gradient. So let's find the gradient of line F, because we've got more information on that line. We've got 2 points on that line, and let's go calculate the gradient. So the change in my y values, my -1 and I'm taking away 2, and then 0 and I'm taking away 3. That is going to give me -3 over -3, which is just 1. So the gradient for line f of x, the orange line, is 1. Since they are parallel, the gradient for our purple line is also equal to 1. They share the same gradient. Gradient of f is 1, so the gradient of our line is also 1. And there we go. It would be, let me just go use the form or the notation that they want me to use. G of x, which is just my y is equal to, there's my m, plus c. And there we go. That is the equation of the line. We don't have to write the 1. And I'm just putting it in there that you can see I'm putting my gradient. And we just found the equation of g of x. Question 2. We clearly were not given a graph that we need to interpret. So with this one, we're going to have to read carefully. Determine the equation of the line. So they want the equation of the line, so we already need to know that that means y is equal to mx plus c, and we're going to have to find the gradient m, and we're going to have to find the y-intercept c with a y-intercept of -2. Okay, so for the line that we need to find, they already gave us the y-intercept of -2, and you need to identify that as our c value, because the c value is our y-intercept. Then they give us more information, that they're saying the line that we are supposed to find, it is parallel to another line. With parallel, you immediately need to know, okay, so these two lines that they're talking about will have the same gradient. So that word parallel is very important there. To the line with the equation that. Now we can see that that is not in standard form. That's okay. We can go put it in standard form. Let's make a quick rough drawing of what's going on. So they're giving us two parallel lines. There's the one. There's the other. Here is the one that we need to find. We need to find that green one. What do we know about the green one? Well, they gave us the y-intercept. So that means we already know for our line that our y-intercept would be by -2. There it is, right? Okay, but we've got that m missing. We've got the gradient missing. We were not given enough information about our line that we're supposed to find to be able to find the gradient. So we're going to have to use the information on that other line. What were we given about that other line? Well, they gave us that we have got an equation there of that. What information, grade 9s, would we like to find from that other line? We would like to find the gradient because in our line, we need the gradient. That's the missing thing, is the gradient. And what do we know about parallel lines? They share the same gradient. So if we find the gradient of the one, we have the gradient of the other. So let's take the equation of that line that we were given and just put it in standard form. Because if we put it in standard form, we will just be able to read the gradient off there. There we go. There is our y-intercept of this line, but we don't need that. We want the gradient of this line. So therefore, the gradient is equal to 3 for both these lines. So what is the equation of our line? Our line, y, is equal to 3. They share the same gradient. And for our line that we're supposed to find, they told us that the y-intercept is -2. And there is the equation of our line.